All right, hello everyone. Today I am giving you an axonometric axes question, a higher level one, which really is a dimetric projection question. It is 2011 higher level. I want to work through it with you. The question is attached to Google Classroom for you. You won't need to print it. I have gone ahead here, not to make the video too long, and I have set up just the start of the question here. So I have the axes already laid out. I have put in the point A and B. I have my surfaces ready to draw in my two end views. And there's only one or two little things I want to go through before I actually start drawing with that. So first of all, we're just going to look at the question and see what that's about. So I just want to zoom in here. Okay, question we're doing is, as I said, 2011. So it said the 3D graphic on the right shows an exit from Dublin's Port Tunnel. The outline of the exit is also shown as a line diagram and in the thought bubble. Figure 2 shows the incomplete dimetric projection. So you don't even need to know it's called dimetric, lads. It's already written there. But incomplete dimetric projection of the tunnel exit, and it's using the axonometric axes method. So we're used to that, okay? Now, what we're not used to is doing it at different angles, so that's what's going to menu here. So we're asked to draw the axonometric axes X, Y, and Z, and then the isosceles triangle ABC. And then draw the elevation and end view oriented as shown. Draw the completed axonometric projection. Now, part E is in the pictorial projection, identify the traces of the simply inclined plane that contains a slope exit. Now, I'm not going to be doing that one today in this video because that is not relevant to what we're at the moment, and we haven't done oblique planes in that sense just yet. Okay, so that's that piece. Then we were given a drawing. So I was told that this was 14 meters. And actually, before I do anything else, let's go talk about scale again for a minute. So when you're given a scale, okay, you take whatever measurement it is you were given. Okay, so in this case, we were told 14 meters needs to be put under a scale of 1:100. Okay, it's up there at the top of the question. So what that means is you convert this to millimeters. Convert it to mm, which means that is the same or the equivalent of 14123 millimeters, because you're multiplying by 1000. So there's 1000 millimeters in a meter. So 1 meter is equal to 1000 millimeters. And then what you will always do is you'll divide that then by whatever number is on the scale. So we're dividing by 100. So this guy is a relatively simple setup because we can cancel out the noughts or the zeros and it becomes 140. So 14 is 140. Now, usually once you've one measurement changed like that or, you know, scaled, it becomes easy then to do every other measurement. Now, having said that, there's only two other measurements on it, and actually there's really only one because it's 3.5. So 3.5 becomes 35. All right, so that's that taken care of. All right, so let's have a look at the question so far. I'll just zoom out. Okay, so far, and yeah, that's decent enough scale, is it? Yeah. Okay, so far I have drawn, as I said earlier on, the axonometric axis. So there's my axonometric axis. Now, this is a bit awkward to do because the angles involved are a little bit, not peculiar, but they're not set square angles. So the 115 degrees, I had to get out the protractor and I had to measure it because my adjustable set square is in school, but certainly an adjustable set square would have made this a hell of a lot easier for me and definitely a lot more accurate. So I started off by drawing in my vertical line here. Now it does fit perfect into an A3 sheet. You might have to work to make it fit, but it fits perfect. Actually, if I look at my proportions I've allowed, it's kind of the same amount there as is above the top point of the triangle, so that might help somebody space it out. And if I look at that, that's kind of about half of that width. Anyway, that's beside the point. Fit it onto your sheet. So I started by drawing z-axis. I projected that on then. I then did the x-axis, projected that on. Y was already there. So I suppose actually I started with the y-axis if I'm truthful. So y, x and z went in. Then I extended out as we would have done in axonometric. Now I suppose it's important to mention here the differences. with the views we've been doing already, the axonometric axis method, we have at ordinary level only been using 30 degrees no matter what. So you would have come along with your 30 degree set square and you would have looked up along this angle, you would have turned your 30 degree set square over and you would have looked up this direction and you would have found a center point. And this green triangle, the important thing, the plane, because that's what it is, it's an axonometric plane. We know now from the sketches, we've seen enough sketches of that, and I'll add some sketches in here to the video as well. But we know from this plane that in axonometric, in what we've been doing previously, it's been an equilateral triangle, whereas this one is an isosceles, which they did say in the question as well. Okay, so what I had to do then was I had to extend on my z-axis. So off I went. And like every other question we've done before, you extend through from the triangle, in this case the isosceles triangle. I drew a line, so these two are parallel, very important. So those two lines are parallel, so sliding set squares was out. And then I bisected that line. Now, just to go over bisection, because I know there's a few of you there that haven't done unit or drawing, but anyway, how do I do it? I set the compass at the end of the line. I open the compass to slightly more than halfway. Doesn't really matter where, but once it's more than halfway, so there it is, I know that's more than halfway. I scribe an arc from this side. I turn the compass around and put it at the other end of the line, and I scribe an arc from the other side. And then when you line those up, those 2 points that we just found, that's what gives you your bisector, and you can see where I did that earlier on already. Okay, so that's bisection. I had to do the same over at this side, except that I gave myself a shortcut, and I'll just explain that for a minute. It's an identical shape at each side, so I left the exact same measurement here between point B and the diameter for the semicircle on point A. And what that meant then is I was able to just bring up my t-square and bring it across. Anything to make it a little bit easier, particularly with the fact that I haven't an adjustable to use for this. So now, ready to start drawing the shape as we're given it. So now it's time to have a look at my actual drawing and try and figure out where I'm going. Now, the first thing I notice, and you might not have noticed this yet, is I don't know that radius there. Okay, when I see R written somewhere, they're usually telling me I need to find it, but I do know it's 3.5 to the top point. But I do also know, and actually I thought I was going to have to go kind of a longer way around this, but if I look at it, this length is also a semicircle because the radius is centered in the center of it, and we're going to be drawing a semicircle. So actually I'll be able to work backwards from there. So that's where I'm going to start. So I'm going to go over there to that triangle. There it is. And like I did a minute ago, I'm going to bisect that triangle and draw in the semicircle. Now, excuse the shadows here. It's not like last summer or last March and April where I was able to do all these in the daytime. It's getting dark outside. It's currently 5 o'clock in the evening. And as a result, I have to use a pile of lamps. So I'll try and move that back. Okay, so compass set slightly more than halfway. Here we go again. 2 arcs scribed, one at either end of the line you are trying to bisect. So they cross there and there. This time they cross a bit closer, it doesn't matter. Join those 2 points. And when you join them, that gives me the bisector. And once I have a bisector, I can draw in the semicircle for the shape of that tunnel. Okay. So there's my semicircle. I'm just going to keep my compass set at that for a minute because some of that is going to need to be heavy. So the next thing I know is I need to come up 3.5 meters. We know that that's 35. And best way to do that would be actually to measure it off a straight line that you already have. So 1, 2, 3, 3.5. Okay, and then we're into parallel. So this is where sliding set squares come in. So I need to go horizontally across. Well, it's not quite horizontal. It's horizontal to this edge. It's parallel to this edge. So I go like that, and that gives me the points that are important and are relevant and are useful and all of those things. Okay, so now I can draw this in heavy. So that is one of my end views done. Now you'll notice that these questions are pretty quick. They're designed to be done in about 25 minutes, even at higher level. So you just got to get the drawing in there and get the drawing done. Okay, I have to move my T-square there now because 7 squares is problematic. So I am going parallel to that line through that point that I just found. And now I'll go back in and heavy in the top of that tunnel. Lovely. Okay, so now, next piece. I'm going to go over here now to this side and put in the measurements and the information. Sorry, I'm pointing probably beyond the screen there, but I'm going to put in this view. So the second end view. And what do I know about it? It is also the width of the triangle. And well, I was going to say it's also 3.5, but of course it's 3.5. It's a view. These are two views of the same thing, so that's important. So over here I go, and I will measure up to 3.5 again. Brings me to a point here. I will go parallel. So I'm moving this T-square again. Remember, you can use a T-square for sliding set squares just as easy as you can use your actual set square. So you're just literally setting up the set square against the line you want to go parallel with, and another set square or another straight edge against any of the other two sides that are left. Okay, so there's that line gone in. I can now heavy this line here as well as I'm at it, as I have it set up, not to be setting it again. And I can also draw in this one. Okay. Okay. All right, so now, okay, in order to put in this top point, okay, I'm hoping most of you will have spotted it, but just in case, it's obviously the radius of this section, because that top edge represents that top point of the curve on the tunnel. So there's a couple of ways you can get that. One is, I still have it on my compass, I do. So I still have the measurement set in my compass, so I can go over here and mark it off. Okay, that's one way of getting it. The other, I suppose, just measure it on your ruler. Beyond that, no, for the moment that's all we need. Okay, so I'm going to go parallel again. Now, try and be as accurate as you can always with measurements, because if they're inaccurate, you'll still be able to draw your diametric, trimetric, axometric, whatever it is, but it'll just be that bit harder to visualize and put it together at the end. Okay, so there is my end view, both end views set up. So now we need to go down. Now they've given us parts of this already, like not half, but certainly most of this is done for us. So I now need to extend down through the views, just like we would have done with plain axometric at ordinary level. We're going to do the exact same thing here. The difference here though is that it's just awkward. So I'm turning my T-square and I'm lining it up with my edge that is at 115 degrees or whatever it might be. And I am projecting down all of these points. Now I need me another colour for projecting down, and I need to top my pencil. Okay, so you can see what's going on. So first of all, down it comes, that point. I hope I've left enough space there now with the border, but if I haven't, I can draw into the border anyway, though I would prefer not to. But sure, look, needs must. Projecting down that point. I'm going to project down anything that they've already given me. So that's already gone down. and they have also projected down this point here. And what I'm going to do then, right, and this is the thing, you should never be measuring in the axonometric at this stage. You should just be matching, for want of a better word. So if I follow that over, that edge is represented by these two edges. So if I go over here now with my adjustable set square, sorry, not my t-square and sliding set squares, and project down. So again, line it up, get nice and accurate. So I'm going to project down this point. I may need to extend that one on in a while. Project down this point. Project down this point and this one. So sticking with the 4 easy ones at the start. Now, if I go over this a little bit with my pencil, well, first of all, if I bring that in, there's a point. Now I know we might need that point because it's at the back. That's okay. I'm still going to just put a dot in at the very least. So there's 1. Follow down further. There's 2. I need to extend that on as I suspected at the start. There we go. 3 and 4. So that's the whole base gone in. And now at the back, the one they've already given us is literally got by projecting them down and see where they match. Projecting them down and see where they match. So in terms of heavying, I can start at least to heavy in here. Here. Now, I was about to heavy across there, but actually, now that I look at the question again, well, one, it's not actually heavy, but secondly, why is that? It's because the tunnel's open. Because I was wondering there for a minute, had they just left it out on the question? The tunnel is open. I now need to bring down the other points. So, setting back up my adjustable set squares, my sliding set squares, I am bringing down this point here. And this guy, and finally this one. So that's everything brought for the moment. Now, we're not quite there yet, mind you, but let's keep working through it. Do the easy bits first. How do you eat an elephant? You eat bit by bit. So bit by bit means I'm working slowly but surely through this question. So now I have those 2 heavy lines gone in. Remember too, when you're drawing, pencil on the point, set square up against the point then and twist the set square to match. Make it more accurate. Okay, so that's that there. Let me just check that camera. Oh yeah, we're okay. All right, so, and I can put this in heavy. Now, I have done everything there that is a straight line. Okay, now we've got to discuss the elephant in the room a little bit that I haven't spoken about at all yet, and that is this curve. Now, if I forget about the curve for a minute and forget about all the rest of it, I can at least, and we've done curves before, so I'm going to run through this fairly quickly because this is not new. I can at least, right, line up my sliding set square there, right, bring it in and draw in the center line of that view. So whatever about the rest of the cabin or the rest of the shape or the rest of the tunnel, sorry, I can at least put in that one because I know that that's the tip top, which is the same here. So I'm just going to give that a point. I'm going to call that point S for a minute because S is over here as well, right? And there's a reason for that. So I'm working my way around it and attempting to put the whole lot together. So if I bring down point S, so again, sliding set squares, S comes down, okay, and again, just matching up one to the other. These are very like puzzles, these questions. Okay, so that's that. Now, also though, the full length of the tunnel, you could say that this is also point S, that it's also a line, it's also an edge. So if that's the case, I should also have, and I didn't, so I'm going to do it now. extend it down S to there. Okay, so I know now my curve is going to run between here and here. I'm going to run between there and there. And actually, bear in mind too, they've already drawn the view of what we're drawing. The only difference is that it's backwards. However, I have a suspicion if I turn it this way, I don't know, can you see that? No, you can't. But if you look through it, if I hold it up to the light for myself, I can see exactly what I'm drawing. So that helps. They also, by the way, gave you a clue. Look at these lines. That's what we're going to draw on the surface in order to generate points for ourselves. Okay, now normally we would put in points at 30, 60 degrees, but what I'm actually going to do is I'm going to put one in here and then one in there, and that should be enough because that's 3, 4, 5 points in total on the curve. Okay, you always need a minimum of 3. We already have 3. Okay, in this case 3 though isn't enough, so 3 might be a minimum, but 3 in this case isn't enough. So I'm just going to pick a point. You can measure one. I'm doing it by eye. I'm going about halfway between these 2 points. And in order to make it even and easier to deal with, I'm going to put that point at the other side at the same height. So mark it in there. Okay. So now I have 2 points. We're going to call them R and P. No, yes, R and P. Okay, now if I am to put in R and P there, what do I need to know about R and P? I need them in the other end view as well. So I need to figure out where they go, and the only way to figure out where they go is by projecting them down like this or imagining them. This is a light line now I'm drawing. It's purely for construction. It's to give me a height. So what do I do with it? I go over here. I measure the height. There's my height, and I mark it off where it needs to be marked off, which is here. And remember, the height is the same for P. So that's what I was doing by making them have the same height. It makes it easier. And then if you imagine that that's like a stripe or a surface, a line, an edge painted on the edge of the tunnel, well, where would that go? It would be parallel to the line SS. So now we have an R, and a PP. So R, comma, P, and the same here, R, comma, P. Now, what we're actually doing, and this is what I want you to remember, every time you've ever done this in junior cert where you've added a point on a curve or divided a circle into 30, 60 in order to generate points, what you've actually been doing is just changing it from being a curve to being something that has 12 sides. So that's all we're doing here as well. And now I continue on, happy as Larry, whoever Larry was, and I project each one of the points just like I did with the corners. The circles are no different, they're just more work. So R goes down, P goes down, and the same thing happens from the right hand side. R goes down, and P goes down, just like that. All right, so back in again with my pencil. So R, where is it? There. So that gives me a point here. P is this line. P is here. So there's a second point. Down here then, R and P. Oh yeah, there's 2 back. I was getting confused there for a minute. I was looking at those points going, what? And then what's going on there? That's the bottom point, and that's the curve on the right. So let's look again. So P comes down here, and P is there. That makes more sense now. And then R comes down here, and R, so there's another one. So we're getting a nice curve, okay? So then when I join up those points, and I join it with a freehand curve, which is smoothened into the top point as best you can. Now, if you've been inaccurate, this is where it'll show up. You might have a bumpy curve, or you might be able to draw a smooth curve. And look, we're not going to worry too much about that at the moment. Now, there is one thing here that by right I should be dealing with, and that is the fact that I don't have an edge point. But this is a strange question in that the edge point is almost the corner point. What I'm saying is by right I should be taking another point in there, but it is so close that it is of no odds, it's of no value to you. All right, so heavy that in, however bumpy it might be. Okay, mine's pretty bumpy. Nothing worse than doing something on camera. Get it wrong. And down here, same thing. Remember too, when you're drawing a curve, that the lines tend to flow into it. There shouldn't be any pointy bits. Okay, the front one is better. Heavy it in as well. Oops. Okay, and there we go. Now, for some reason, I'm looking at this jutting out and it just doesn't sit right with me. Although actually, if I look at the question here, yeah, there's a thing. It's not as, sure, it's not a smooth transition into the straight edge, so that's okay. So there we go. Not quite there yet though, and this is the bit that people would have forgotten, right? 1, I need to heavy that in. And most people got that, that would have been grand. But what a lot of people would have forgotten, if this is to be light, well then this has to be heavy back as far as the back corner, but because the back corner is hidden by that curve, that's where it stops. So now we have ourselves a solution. All right, so there we go. So without doing part D, that is the solution to my question. And I will put a copy of that up on Google Classroom as well. I want you to try it. I want to see how you get on, and I want to move on then as well. By the end of the week, I want to be moving on to a new topic. All right, lads, best of luck with that. Thank you.